Hey everyone. Have you ever just paused to think about the everyday magic happening right in the palm of your hand? I mean, every time you unlock your phone with Face ID, or ask Siri what the weather's going to be like, or even get that eerily accurate food recommendation on Zomato, you're actually interacting with artificial intelligence. It's everywhere. Today, we're going on a completely step-by-step learning journey. Think of it kind of like opening one of those Russian Matryoshka dolls. We're going to start at the outermost shell and unpack it, layer by layer, all the way down to the core of what powers today's most hyped tools. Welcome to our complete beginner explainer on the absolute fundamentals of AI.
Okay, so here's our roadmap for today's one-shot beginner course. We're going to cover Section 1, the true meaning of AI, Section 2, the foundation of machine learning, Section 3, types of machine learning, Section 4, neural networks, and finally, Section 5, generative AI and LLMs. I promise you, by the time we get through these nested concepts, you're going to confidently understand the whole alphabet soup of AI. Let's get into it.
So, let's start with the outermost layer of our Matryoshka doll, Section 1, the true meaning of AI.
The core concept of AI is actually remarkably simple. Basically, it's any technology that allows computers to perform tasks that typically require human intelligence. Think about stuff like pattern recognition or visual analysis. A really great practical example of this is those automated traffic cameras. Now, humans are naturally great at looking at a car and reading the number plate, right? But AI allows a computer system to look at that exact same visual data, detect the plate, read the numbers, and literally instantly generate a traffic challan or ticket. So it's essentially human-like intelligence, but completely automated.
All right, let's open up our doll to the next layer down. Section 2, the foundation of machine learning. This is the incredibly data-hungry engine that is actually driving modern AI apps.
This is where things get really interesting, because it represents a massive paradigm shift in computer science. For decades, traditional algorithms worked kind of like a strict baking recipe. You gave the computer an input, a programmer wrote hard-coded, incredibly rigid rules for it to follow, and boom, it gave you an output. But machine learning, it completely flipped the script. In ML, you give the computer the input and the past output data, and the machine actually learns the rules on its own. It figures out the underlying logic directly from massive data sets, rather than relying on a human to sit there and manually write out every single rule. It's a total game changer.
So, you're probably wondering, how does it actually learn those rules? Well, it all comes down to a super simple two-step loop. Step 1 is training, and Step 2 is inference. Think of it like a bank loan application. During the training phase, the model looks at literally thousands of past applications. It's analyzing salaries, credit scores, and whether those specific past loans were ultimately accepted or rejected by human bankers. It's learning the pattern. Then comes Step 2, inference. When a totally new applicant walks through the door, the model uses that logic it just learned during training to infer, or basically predict, whether this new person should get the loan. Train on the past, infer the future. Simple as that.
Okay, now that we know how it works in theory, let's peel back to our third layer. Section 3, types of machine learning. We're going to see the distinct ways machines actually learn from all this data. There are essentially three main branches on the machine learning family tree. We've got supervised learning, which uses labeled data, unsupervised learning, which relies on raw, unlabeled data, and reinforcement learning, which is entirely based on a system of rewards and penalties. Let's break these down one by one so they make total sense.
First up is supervised learning. This is where we train a model using perfectly labeled data to predict future labels. Honestly, it's kind of like giving the computer an answer key to study from. A perfect everyday example is your Gmail spam filter. Gmail trains its classification algorithm on millions of past emails that users have clearly labeled as either spam or not spam. The machine studies the exact characteristics, like maybe all-caps text or super shady links, and then uses those newly learned rules to automatically catch future incoming junk mail.
Now, let's see how this builds into something called regression, which is just another flavor of supervised learning. When we have perfectly structured inputs and outputs, like mapping a bunch of people's heights to their weights, the algorithm can actually draw a mathematical line right through that data to predict exact numerical values. And guess what? This is exactly how delivery apps like Zomato or Swiggy predict a precise 43-minute delivery time for your food. They regress the distance and current traffic data against thousands of past delivery times to give you that exact number.
But wait, what happens if our data doesn't have an answer key? Well, that brings us to unsupervised learning.
Here, the algorithm just gets raw, completely unlabeled data and has to find the hidden patterns all on its own by grouping things into clusters. Imagine just tossing thousands of random, unlabeled news articles at an AI. An unsupervised learning algorithm will automatically group them into distinct clusters, like tech, politics, or sports, purely by analyzing the inherent similarities in the words being used. Absolutely no predefined categories required from us.
Because unsupervised learning is so incredibly brilliant at finding these hidden connections, it perfectly solves what we call the association problem. A really fascinating application of this is market basket analysis. Have you ever wondered how Amazon or Blinkit know exactly what you want to buy next? Well, they analyze massive data sets of raw, everyday shopping carts. The algorithm automatically figures out that, hey, if a user puts bread in their cart, there's a ridiculously huge probability they'll also want to buy milk right after. It finds that association entirely on its own.
Okay, so the very type of machine learning is just absolutely fascinating. Training a reinforcement learning model is genuinely just like training a pet dog with treats and penalties. Imagine tossing your dog a treat for doing a good trick, right? Well, in reinforcement learning, an AI agent is dropped into an environment. It makes a guess or takes an action. If it does well, it gets a mathematical treat, a reward. If it messes up, it gets a penalty. The agent's ultimate goal is just to maximize those rewards through pure, relentless trial and error.
And because it relies so heavily on trial and error to master an environment, reinforcement learning is used for incredibly complex, multi-step challenges out in the real world. We're talking about AI playing and completely mastering complex games like chess and Go, figuring out the absolute optimal way to win at snakes and ladders, safely navigating chaotic city roads in self-driving cars, and even teaching literal physical robotics how to walk and pick up objects. It's wild stuff.
We are making incredible progress here. Let's pop open the Matryoshka doll to our third major layer. Section 4, Neural Networks. This is the absolute key to unlocking highly complex data. There's a really clear contrast here. Traditional machine learning is awesome for structured data. You know, those neat, organized Excel tables for bank loan stats. But what about unstructured data? I'm talking images, video frames, text messages, the messy, totally unpredictable pixels of human faces. You can't just easily paste a human face into a neat little Excel spreadsheet, right? That's exactly where deep learning and neural networks come in. They were designed specifically to extract patterns from this chaotic, complex, unstructured data where manual feature extraction by a human is just nearly impossible.
So, neural networks are actually directly inspired by the human brain, and they learn through a really intense trial and error loop. Step 1 is forward propagation, which is basically where the network makes a prediction. Then comes step 2, backward propagation, where it calculates its mistakes, which we call its loss, and physically adjusts its internal weights to learn from that mistake. Think of it like a college grading system for your CGPA. If a teacher notices everyone is skipping the class tests, they might adjust the weight of that class test to be worth way more and reduce the weight of the final exam. A neural network does this exact same mathematical adjustment, but millions of times over, just to perfect its prediction formula.
And depending on what kind of messy data we're actually feeding it, we use specialized neural architectures. First, we have standard FNNs, or feed-forward networks. Next, we have RNNs, recurrent networks, which have this sequential memory that makes them absolutely perfect for text. Then we have CNNs, convolutional networks. These process data in grids, making them total powerhouses for efficiently reading image pixels. And finally, we have transformers. This is a revolutionary architecture that uses an attention mechanism to understand the deeper context of entire sentences all at once.
Which brings us right to the innermost, most hyped layer of our entire Matryoshka doll. Section 5, Generative AI and LLMs. Let's look at the actual mechanics behind today's biggest viral tools.
So the absolutely crucial point here is this fundamental shift in what the AI is doing. Up until now, everything we've talked about, from classifying spam to predicting Zomato wait times, has been about analyzing existing data. Generative AI moves way beyond just predicting or classifying. It focuses entirely on creating brand new, totally original text, images, audio, and video that has literally never existed before in the world.
And this brilliant new frontier has just birthed a booming landscape of tools that are completely dominating the market right now. Over in text, we've got ChatGPT, Anthropic's Claude, and Google's Gemini. For generating those breathtaking images, there's Midjourney and Stable Diffusion. We're now generating incredibly realistic video with tools like Sora and Runway, and developers are even generating software code on the fly with GitHub Copilot. Categorizing them by medium like this gives you a really nice instant structural understanding of the whole generative AI explosion.
At the very heart of this text-based GNI revolution are two massive buzzwords you've probably heard:
NLP, and LLMs. Natural language processing is basically the broader field of teaching machines to understand and interpret human language. Large language models, like the famous GPT-4, are massive transformer networks. They have been trained on absolutely internet-scale volumes of text, and their core mechanism? It's surprisingly simple. They just predict the next text token, which is essentially just a tiny chunk of a word, over and over and over again, at massive scales, to generate language that feels completely, authentically human. Well, look at that! We've unboxed the entire Russian doll today. From the basic definition of AI, to the data-driven roles of machine learning, to the deep neural networks that mimic our own brains, all the way down to the large language models powering today's massive generative revolution, you now have a super solid, step-by-step foundation in the fundamentals. So I'm going to leave you with this final thought. Now that you truly understand AI and have decoded all that alphabet soup, what are you going to use it to build? Keep exploring, stay curious, and I'll catch you in the next explainer.